So we've talked about a few of the different kinds of variables, but there are actually two main types and then two subtypes for each of these main types. We can think of variables as either being qualitative or quantitative, or to put it another way, we can think of variables as being categorical or numerical. It means the same thing. When we talk about a numerical variable, sometimes people will call that a quantitative variable. When people talk about a categorical variable, sometimes people will call that a qualitative variable. But it's useful to distinguish between these two main types of variables. Numerical variables, they are variables that simply take on values that are numbers. So for numerical variables, it usually makes sense to add, subtract, or take numerical summaries such as averages of these values. So some examples would be an age of a respondent, the miles per gallon in a car, or the ranking of different colleges, in which, suppose you have 4 colleges and you want to rank each of these 4 colleges from 1 to 4. Well, each college gets a 1, 2, 3, or 4 ranking. For numerical variables, it's useful to further distinguish between continuous numerical variables and discrete numerical variables. For a continuous numerical variable, it can be assigned, it can take on any number. So, for example, height in inches, or percent of children living in poverty, or the number of miles you might have moved away from your childhood home. Each of those variables are continuous in the sense that it makes sense. It's possible to have many decimal places. So your height in inches might be 70.23589 inches. In contrast with discrete variables, discrete numerical variables, they can take on values that are only non-negative counting numbers. So 0, 1, 2, 3, 4, 5, and so on. So these kinds of variables, discrete numerical variables, they have certain jumps between each of the values that it can take on. So a discrete numerical variable cannot have a value of 1.5. It doesn't make sense. It can't have a value of 3.42. It only can take these values of non-negative counting numbers. So some examples might be the number of votes for a politician. When you count votes for a politician, the votes are non-negative counting numbers. A politician might get 3 votes, or 500 votes, or 1,000,000 votes. But a politician can't get 3.5 votes unless there's electoral fraud going on. If you look at a sort of a different example, if you look at the rating of a restaurant on a 5-point scale, assuming that scale just consists of 1, 2, 3, 4, and 5, that is a discrete numerical variable. Another example would be the count of the arrivals at an airport. So how many arrivals occur at an airport in a given day? Well, that's going to be a count. That's going to be a discrete numerical number. You might have 500 arrivals at an airport, but you won't have 500.5. So the key point between continuous and discrete numerical variables has to do with whether or not they can take on all sorts of numbers or just non-negative counting numbers. So let's go through a few examples. The annual household income of a respondent in thousands of US dollars, that's an example of a continuous numerical variable because you have these decimal places that dollars can take on. A rating from 1 to 4 stars of a movie, assuming that the stars are 1, 2, 3, and 4, that's a discrete numerical variable. To give another example, the number of murders last year in a neighborhood would be a discrete numerical number because for that kind of variable, you only can take on 0, 1, 2, 3, 4, and so on. Besides numerical variables and their two subtypes of continuous and discrete, it's useful to talk about the other main type of variables you will encounter, which are categorical variables. Categorical variables, sometimes called qualitative variables, they take on values that have different categories or qualities. Sometimes you'll hear a categorical variable referred to as a factor, and the different categories or qualities that a categorical variable can take on are sometimes called levels. It means the same thing. If somebody talks about a factor with different levels, they're talking about a categorical variable with different categories. Here are some examples of categorical variables. Gender of a respondent. In general, it would be male or female, so you have these two categories. You might talk about approval or disapproval of a social policy. Or you might talk about whether somebody's a regular smoker or not. So yes or no, do you smoke regularly or not? These different kinds of variables are categorical in the sense that there are these different categories or qualities. The two subtypes of categorical variables are nominal and ordinal. For nominal categorical variables, there's no inherent order to their categories or levels. So for example, religious identification, political party affiliation, or the names of countries you have visited in the past year. Each of these nominal categorical variables, they're nominal because there's no inherent ordering. It doesn't make sense to say that for religious identification that Catholic is somehow higher or lower than Protestant, for example. So for nominal categorical variables, there's no inherent ordering. For ordinal categorical variables, there is usually an expected ordering. It's sort of natural or inherent ordering to the different categories or levels. So for example, you might talk about the highest educational degree a person has attained, or the level of approval in a country's economic policy, from strongly disapproved to strongly approved. Each of these ordinal variables, they have an ordering to them. So when you talk about the highest educational degree someone has obtained, a graduate degree is naturally higher than a high school degree. So, or if you talk about approval, it makes sense to order the different levels so that strongly approved is the topmost category, then below that might be somewhat approved, and below that would be somewhat disapproved, and below that would be strongly disapproved. For ordinal categorical variables, it makes sense to order the different levels. However, it's not always clear-cut, because one person's idea of what a natural ordering is, it might be culturally specific. Maybe if you go to a different person or a different society, there is no inherent ranking that's obvious to people for different levels of a categorical variable. So keep in mind that if you're unclear about whether a categorical variable is ordinal versus nominal, you should probably stick with it being nominal, just because in ordinal variables there's a certain subjective component to saying that certain levels are higher or lower than others. For this course, we are going to talk about the different subtypes of numerical versus categorical variables, but we will focus in particular on this main distinction between numerical and categorical variables. That's the key distinction. It's useful to know the subtypes, but the sort of main data analysis decisions that you make for this course will be based on whether you have a numerical variable or a categorical variable. So let's look at our data set of states again. So as a reminder, the rows are the observational units, are US states, and we have these different characteristics, these different variables of each of these states. So let's go through our columns of our data set and say what type of variable is each column. That first column is state. It's the name of a US state. That is a categorical variable, and it's nominal. And the levels of this categorical variable are the different names of the states. You might have Alabama, Alaska, Arizona, and so on to Wisconsin and Wyoming. For that column, it's nominal because there's no inherent ordering to the levels. And it's categorical because we have these different qualities or categories for that variable. If we go to the next column, we have this variable for region, geographic region of the US state. This is also categorical, and it's nominal because there's no inherent ordering to the levels. The levels, or the categories here, are Northeast, Midwest, West, and South. So we have 4 levels for this single categorical variable. For the variable high school in the 4th column, this gives the percent who graduated from high school. This is a numerical variable because we have these values of numbers, and it's continuous because it can take on decimal places. So the values are different numbers such as 90.2 and so on and so forth. And then let's look at this other variable of population in millions. This is also numerical, and it's continuous because it can take on decimal places as well. Let's look at our data set and just summarize. So we have 2 categorical variables and we have 2 numerical variables. Both of the categorical variables are nominal, and both of the numerical variables are continuous. So for this first part in our discussion of what a data set really consists of and our introduction to data, you should know that a data set is really just consists of a set of observations about the world around us. When we take sort of raw observations and we organize them into a data set, we call that a data set, sometimes known as a data frame. The rows of a data set are the cases or observational units, and the columns we call variables. They're characteristics of the cases. And then in general, variables may be numerical or categorical, and then among numerical variables, we like to distinguish between continuous and discrete variables, and among categorical variables, we like to distinguish between ordinal and nominal variables. And with that, we will end our discussion for now about what data sets really consist of and the different types of data you will encounter.